This video is brought to you by mywayteaching.com.
Let us consider few examples, or we can say some special cases. Okay, the first one is position time graphs of two objects with equal velocities. Okay, in this case, if vb is equal to va, okay, if the velocity of object B is equal to the velocity of object A, then we can say VB minus VA is equal to 0, isn't it? Then from equation, that is XBA of t that we got previously, that is XBA of t is given by the position of object B with respect to A is given by xb of 0 minus xa of 0 plus vb minus va into t. Okay, so we can from this equation we can say that xp of t minus xa of t is equal to, this xp of t is nothing but what, xb of t minus xa of t is equal to xp of 0 minus xa of 0, because this vb minus va is 0 in this particular case. Therefore, the two objects stay at a constant distance xb of 0 minus xa of 0 apart. So in this figure you can see the two objects are at a constant distance, isn't it? The distance between these two is constant. This is because of this reason. And their position time graphs are straight lines parallel to each other, as you can see in this graph. So the position time graph is a straight line, isn't it? And the lines, the position time graph for the object A is parallel to the position time graph line of the object B. The relative velocity VAB or VBA is 0 in this case. So we already saw that one. Okay, the relative velocity, since VB is equal to VA, the relative velocity, that is VBA, is equal to VAB is equal to 0 in this particular case. Moving to the second one, the position time graphs of two objects with unequal velocities showing the time of meeting. See, if we consider two objects A and B, where the velocity of object A is greater than the velocity of object B, then VB minus VA is negative, because the velocity of object A is greater. So obviously VB minus VA will give a negative value. So one graph is steeper than the other, isn't it? One graph is steeper than the other and they meet at a common point. So in this figure you can see they meet at a common point. For example, suppose VA is equal to 20 meter per second. You just assume VA is equal to 20 meter per second and XA of 0 is equal to 10 meter. The position of this object A, initial position is 10 meter and VB is given by 10 meter per second and XB of 0 is given by 40 meter. Okay, then the time at which they meet is t, that is given by 3 seconds, as you can see in this figure. At this instant they are both at a position, that is xa of t and xb of t both are at the same position, isn't it? xa of t and xb of t at that common point of meeting are at a position, that is at 70 meters. Thus, object A overtakes object B at this time. In this case, VBA is given by minus 10 meter per second. VBA, we know VB is how much? 10 and VA is 20. So, VBA is equal to minus 10 meter per second. So, here object A overtakes object B. Moving to the next part, that is position time graphs of two objects with velocities in opposite directions showing the time of meeting. Suppose VA and VB are of opposite signs. Okay, VA is moving in one direction and opposite to that another object B is moving. So VA and VB are in having opposite signs. For example, in an example, let us take a very simple example. Object A is moving with 20 meter per second starting at xa of 0, that is 10 meter. So object A is moving at 20 meter per second. Okay, and it is starting position is given by 10 meter. And object B is moving with minus 10 meter per second. Okay, starting at xb of 0 is equal to 40 meter. The two objects meet at x is equal to 1. You can see that in the figure. Okay, they meet at t is equal to 1. So the velocity of B relative to A, that is VBA, is given by VB minus VA, and VB is minus 10 and VA is 20. So that VBA is minus 30 meter per second. In this case, the magnitude of VAB and VBA is greater than the magnitude of velocity of A or that of B. If the objects under consideration are two trains, then for a person sitting on either of the two, the other train seems to go very fast. Okay, here this VBA, the magnitude of VBA as well as VAB is greater than the velocity of VA and velocity of VB. If we consider these two objects as two trains, then for a person who is sitting on either of these two trains, the other train, it seems to go very fast because VAB or VBA is very much greater than the individual velocities, that is VA and VB. So let us see simple problem on this. Two parallel rail tracks run north-south. Train A moves north with a speed of 54 km per hour and train B moves south with a speed of 90 km per hour. What is the velocity of B with respect to A? So first they are asking us to find VBA. What is the velocity of ground with respect to B? So they are asking us to find the velocity of B with respect to ground. And the third one is velocity of a monkey running on the roof of train A against its motion with a velocity of 18 km per hour with respect to train A as observed by a man standing on the ground. So let us find the solution for this. Choose the positive direction of x-axis to be from south to north. From south to north, let us take it as positive x-axis. Okay. Then VA is given by 54 km per hour. If you convert it into meter per second, then it will become 15 meter per second, and VB is given by minus 90 kilometer per hour, that is nothing but 25 meter per second. Relative velocity of B with respect to A, that is the first question. Relative velocity of B with respect to A is given by VB minus VA, where VB is minus 25 and VA is 15. So we get it where the answer is minus 40 meter per second. The train B appears to A to move with a speed of 40 meter per second from north to south. Relative velocity of ground with respect to B, that is given by relative velocity of ground with respect to B is given by 0 minus VB, that is given by 25 meter per second. And in the third case, they are asking us to find the velocity of a monkey running on the roof of the train A against its motion, which means if the train is moving like this means the monkey is moving opposite to this. Okay, and with a velocity of 18 km per hour with respect to train A as observed by a man who is standing on the ground. Okay, let the velocity of the monkey with respect to ground be Vm. Relative velocity of the monkey with respect to A, that is what asked in the question, that is VMA, that is given by Vm minus VA. Vm they have given minus 18 This VMA, they have given it as minus 18 kilometer per hour. Okay, that is given by minus 5 meter per second. So now we know VMA, so we have to calculate VM, that is given by VMA plus VA. So VMA is nothing but 15. So VMA is nothing but minus 5 and VA is 15. So we will get 10 meter per second.